Good evening, everybody. Welcome back to the integral series. And today I would like to talk about the 2023 Integration B. It's an annual event. It's hosted by MIT, and it's pretty much sum up like uh, you get together. You have a lot of smart people get together, and they was what's that elated, excited to solve integral and to comment about the people how they solve integral. It's like a football match, like a soccer match. So it's a very very exciting event. Okay, and it's on YouTube. So if y'all interested, you can watch the different years where they host it. But it's pretty interesting. It makes you happy. So. I'm interested today. We're interested in a particular problems, right? So we let me go ahead and write a problem down for y'all. So, original problem. So they asked us to evaluate the integral from 0 to pi of sine 2x times sine 3x times sine 5x times sine 30x over sine x times sine 6x times sine 10x times sine 15x. Okay, dx. And all of this square. Okay, that's what they're asking us for. And no, we're not gonna solve it completely today. In fact, I will give you all a link down below where they solve it. So I believe let me go ahead and do this. So Wong solve the problem completely. Complete solution link below. And I think the YouTube channel, I think his name is Mats505. Yeah, I'm gonna give a link below for y'all. So yeah, this is the integral. So you see it's a multiplication, is a division of trigonometry multiplication, and then they square it, and they ask you to find a zero sum 0 to pi. Now, what I'm gonna do actually today is to prove a lemma, which will be extremely useful in these problems. Purpose, prove an important lemma, or theorem. You're gonna encounter that word a lot in mathematics. I think lemma, theorem, which will be useful for this problem. And later on, after I finish the demonstration, you guys can verify using, if you use Mathematica. So let me write, can verify using Mathematica. Okay, so what is the theorem? So the theorem, let me write in red, it will be our what you call it, our divisions. So sine 2x times sine 3x times sine 5x times sine 30x over sine x times sine 6x times sine 10x times sine 15x. It will be equal to -1 minus 2 cos 2x plus 2 cos 6x plus 2 cosine 8x. Okay, so to be honest with y'all, at first I didn't know like the left hand side go to the right hand side. I was like, oh my gosh, how can you simplify this division, right? How can it get a nice result like the right hand side. I didn't know, and then I put it into Mathematica, and I used the simplified functions of Mathematica, and it gave me this result. So today let's utilize our human side. Let's see if we can manually or by hand prove it's correct. Okay, so let's go ahead and hopefully we can convert the left hand side to the right hand side. Okay, so what you're gonna do? So the first thing we're gonna do is I would say we're gonna need to use something if you don't remember. So first lemma we're gonna use. We're gonna use sine 2 plus v equal sine u cos v plus sine v cos u. Okay, or in other word, sine 2a, if you replace u with a and v with a, so you had sine 2a equal to sine a cosine a. Okay, so with that being said, our left hand side, or this term right here, I draw the dash line, is gonna be sine 2x. I will replace with 2 times sine x times cosine of x. Sine 3x is 3 is the odd number, so I'm just gonna leave it like there. Sine 5x, I'm gonna leave it right there. Sine 30x is 2 times 15, so you get 2 times sine 15x times cosine of 15x, right? And that is for our numerator. What about our denominator? So sine x, I'm gonna rewrite it. Sine 6x, 6 is 2 times 3, so I replace sine 6x with 2 times sine 3x times cosine 3x. Okay, sine 10x, well, 10 is 2 times 5, so I replace with 2 times sine 5x times cosine 5x. And sine 15x, I keep the same. Okay, is everything clear so far? All right, so let's see what term we can cancel out. So if you look at the denominator, okay, we have sine 5x will go away, 2 will go away, 2 will go away, and then sine x will go away. Sine 3x is it going away? No. Sine 15x is gonna go away. All right, so what left is cosine x. Oh, my bad. Sine 3x also go away. So sine 3x. Okay, let me check. Yeah, sounds right. So what left is cosine x times cosine 15x over cosine 3x times cosine 5x. Wonderful. What we're gonna do next is, I think we need another lemma, another small theorem, supporting tools, to further simplify this. Y'all notice that 15 is 3 times 5, right? So let's go ahead and see what is cos 3a. So let's go ahead and expose this term, right? So explore, sorry. So lemma 2. We're gonna study this what's it called, ratio. Okay, so cosine of 3a over cosine of a. Let's see what it's equal to. Okay, so you know that cosine 3a you can write as cosine of 2a plus a over cosine of a. So this would be cosine of 2a times cosine of a minus sine 2a times sine a, okay, over cosine of a. This is basically just the definition for cosine of u plus v, okay. And then we can further simplify it. You see cos 2a is cos a. The goal is to divide by cos a. Okay, So you see this sine 2a right here. We can go ahead and use the previous lemma we only show. So you can write cos 2a times cos a. Remember, in mathematics, if you see something that is unchanged, just keep rewriting it. Just substitute in the variables or expression needs to be changed. Okay. So in this case, sine 2a, I'm gonna substitute it 2 times sine a times cosine a times sine a, okay, over cosine a. And we can cancel the cosine of a out. So here and then here. So you get cosine of 2a minus 2 sine square a, right? And if you recall, what is cosine of 2a? Cosine of 2a is cos a plus a, which is 2 cosine a minus 1, okay? And sine square a, you can replace it with 1 minus cosine a square, because sine square plus cos square equal 1. So sine square equal 1 minus cos square. Okay, so if you simplify this expression, you get 2 cosine a square minus 1 minus 2 plus 2 cosine a square equal to 4 cosine square minus 3. Okay, wonderful. So if we apply this theorem, what will we get? If we apply this theorem right here, apply lemma 2, you will get cosine of 15x over cosine of 5x equal to cosine of 3 times 5x over cosine of 5x. And we have shown that 3a over a equal 4 cosine square a minus 3, right? So 3 times 5x, so 5x would be, just treat 5x as a, okay? Just treat 5x similar to a, and you would get 4 times cosine square of 5x minus 3. And by the way, when I write this term, cosine square of 5x, it means that it is cosine of 5x square, okay? You might see this a lot in trigonometry problems. I just want to clarify this out because sometimes even me, I got confused too. So it's worth pointing it out. All right. So similarly, cos 3x over cos x. It's very simple, right? So it's just 4 cosine square of x minus 3. Okay, wonderful. So if we plug in our left hand side, we'll have what? We'll have our left hand side is actually where were we again? Here, we were here. So cos x times cos 15 over 3 times 5. Okay, so cos x times cosine of 15x over cosine of 3x times cosine of 5x. I'm gonna do some rearrangement, so I can say this cosine of 15x over cosine of 5x over cosine of 3x over cosine of x. Okay, you guys agree with me? Cosine 15x over cosine 5x is 4 cosine square 5x minus 3, and cosine 3x over cosine of x is 4 cosine square of x minus 3. Okay, so this is where we are so far. I'm gonna stop the video, and in the next video we will finalize this problem and see how this ratio we're having right now, as in blue star, will get us this right hand side, which is -1 minus 2 cosine 2x plus 2 cosine of 6x plus 2 cosine of 8x. Okay, I appreciate everyone's attention, and I'll see you in the next video.